In section 6.3, we'll talk about the differences between state functions and path functions. Throughout the remainder of chapter 6, we'll continue applying these concepts to predict energy changes in reactions. Our learning outcomes only reiterate the author's learning goals on the previous slide, so let's begin. Suppose two people both need to get to the 6th floor of a building. One takes the elevator from the ground floor directly to the 6th floor. The other person takes the elevator from the ground floor to the 10th floor before going back down to the 6th floor. They both start from the ground floor, and the result for both people is the same. They arrive at the 6th floor. So the path they took to get there is irrelevant in that sense. A state function describes the current state of the system and is independent of the path taken to achieve its value. Internal energy, U, is a state function. Let's consider this further with an example. Suppose you take 20 grams of solid ethanol and heat it to form liquid ethanol at 25 degrees Celsius. You could also condense 20 grams of gas phase ethanol to liquid at 25 Celsius. Either way, the liquid ethanol has a specific internal energy, U liquid, that is the same, regardless of the path taken to achieve that state. However, the heat or work associated with the formation of the liquid ethanol is different in the two cases. Melting solid ethanol requires a positive input of heat, while condensing gas phase ethanol requires heat to be removed. This tells us that heat and work are not state functions because they are path dependent. The values of path functions depend on the sequence of steps required to move a system from its initial to its final state. Path functions, therefore, do not describe the current state of the system, but rather how the system moves to achieve a particular state. Path functions include work and heat. Is temperature a state function or a path function? Temperature describes the current state of a system and does not depend on the history of the system. Therefore, temperature is a state function. As always, I'll leave you with the parting thoughts of the authors.